Hello, chemistry class. It's Mr. Ng, and I have some practice problems for you. I want to go through how to convert from mass to moles and moles to mass. And here, these are some sample problems out of your homework set. We want to convert 10 moles of chromium into grams of chromium. If you check out our graphic organizer here, we're starting at chromium, right? And then we want to get over to mass, so we're going to use this little conversion factor up here. Or we could just follow the rules of dimensional analysis that we've been doing like all year long. Let's start with our given, A. Our given is 10.0 moles of chromium. And as you know, to get out of this unit, we put the unit on the bottom, moles of chromium. And we want to go to mass, which is going to be in grams. So up here, we're going to write grams of chromium. Whenever we're doing molar masses, right, we just kind of look at the periodic table. So here I have a snippet of the periodic table already written out, and it's 51.996 grams of chromium over 1 mole, right? 1 mole of chromium weighs this much. That's what this number is trying to say. So all I got to do is multiply across, and I get 520 grams of chromium. Seems easy enough. Let's try another one. Let's try F. F, I have 0.16 moles of water, H2O. You know, I better slow down and find the molar mass of water. Here, we're going to count all of the masses inside this molecule. We have 2 hydrogens, and we have 1 oxygen, right? Each hydrogen weighs 1 gram. That's what I'm seeing right here, 1 gram. And this 1 oxygen weighs 16 grams. Okay, this is just how we find molar masses. You add these together. This is 18 grams per mole of water. So now we get to use this sucker. So our given is 0.160 moles of water. And again, to get out of moles, we write moles on the bottom of water. And we want to get into grams of water. 1 mole of water weighs 18 grams, right? Usually when we do these molar masses, just have the 1 and the mole kind of married together. If it's the mole to mole relationship, like how we do in stoic, then you have to look at the balanced equation. But here, when we do molar masses, we're always going to be dealing with 1 mole. So I just have to multiply that across. And when I do multiply that across, I get 2.88 grams of water. Seems easy enough. Let's continue. What if we needed to go the other way around? What if we were going from mass to moles? From mass, meaning right here, to moles, then we're going to use this conversion factor down here. We're going to have masses on the bottom. So what's our given in part A? Part A, we have 72 grams of argon. So same rules apply. If we want to get rid of a unit, in this case we have grams, our given is in grams. So we're going to write grams on the bottom, grams of argon, and we want to go into moles. So we're going to write moles of argon on top. I know that 1 mole of argon weighs this much, 39.948 grams. If I multiply that across, actually I'm not going to multiply, I'm going to divide because it's on the bottom, right? You're going to divide. I get 1.80 moles of argon. Good. Part B, I have NO3, right? So before I do anything, I got to find the molar mass of NO3. So NO3 has 1 nitrogen and 2 oxygens. Each nitrogen weighs right here 14 grams plus 2 oxygen. Each oxygen is 16 grams. So if I add that up, I will get 46 grams per mole NO2. So now I could do my simple dimensional analysis. My given is 27.4 grams of NO2. I want to get out of grams, so grams on the bottom. grams of NO2 on the bottom. I want to get into moles, right? So moles of NO2 on top. 1 mole of NO2 weighs 46 grams. Oops, I don't need to write grams again. So I just have to divide across, and I get 0.596 moles of NO2. There you go. So a couple of things to do with these mole to mass conversions. What you start with, you're going to put on the bottom of your conversion factor. If that's kind of goofing you, then you could just use this graphic organizer. It kind of shows you, right? If you're going from mole to mass, you put the molar mass on top. If you're going to mass to moles, you put the molar mass on the bottom. And I think most of us know how to do molar mass, so that should be pretty easy for you. Thank you very much for watching.